Hello everyone. I picked job number 18 to do a video over. I'm going to add it to our lab, make a video quiz out of this, and give you an opportunity to use both your voltmeter and your amp clamp to do some troubleshooting. And so if we look at this circuit, what we have, of course, it's 110 volts. We have L1, L2 coming in. We come through a start winding, come through a single pole, single throw switch into 4 capacitors wired parallel to one another. And what is unique about this job is because we have loads parallel, equal loads parallel to one another, we can use both tools, amp clamp and voltmeter, to use the troubleshooting Bible and see things such as opens when they're parallel and shorts. And the unique factor in a short is, of course, when loads are parallel, if one load is shorted, that load will shunt the rest of the loads. And so reviewing our troubleshooting Bible, of course, it starts if we have volts and we have amps, we are good. And so I'm going to turn the power on here. And you can see that I have a total, there's no bugs in this right now. I have 5.5 amps and 120 volts coming into the circuit. I come through the start winding, and so I'm going to lose some voltage there, of course, and then I can come down to my capacitors and I can see a voltage drop. Comes to 107 volts. So I have amps and volts to load 1, meaning that that is good. Okay. If I have volts and no amps, that's open. If I have amps and no volts to a load, that is shorted. And if I have no volts and no amps to a load, that means look either to the source for no power or look to a parallel load for a short, because that would be shunting that load. So if I had no volts and no amps to load 2, that would mean possibly that one of these other loads are shorted, shunting that. So let's troubleshoot this. What I will do is I will put a bug in it. I will do the steps that I would do as a technician to find the problem, and I will pause there for you to be able to interactively answer the question and find out what's wrong with it. So once again, I have 5.5 amps working on the total amperage and 107 volts coming to my loads. So I put a bug in it, turn the power off, turn it back on. Okay, I have volts coming to it. Now I can see my amperage, my total amperage has dropped, but I still have amps coming to it. So that would mean that I have a possibility of amperage going through this capacitor, but is it the same amperage here? Let's see. It is the same amperage from here to here. So if there is 4.4 BBs traveling down this wire here, and I still have 4.4 BBs coming this way, did any go that direction? I don't think so. So let's see if there's any more amperage drop. There is. Some of the BBs went through there. Some of the BBs went through there, and then the last amount of the current flow goes through this right here. And so I had no amps here and volts. Okay, bug number 2. Turn the power on. I can hear a change. I have a lot of amps, 11.7 amps total and no volts. Okay, so I'm just going to quickly come down through here. I have no amps there, no amps there, no amps there. I have 11 amps coming to the parallel loads, and then no more amperage goes to these bottom 3. So load number 1 has no volts and 11 amps. Okay, let's look at another bug. Turn it on. I have 4.4 amps total coming down. So I know that I'm doing some work. I have 113 volts. Let's look for amperage drop. Did I lose any amperage through the first one? I did. Did I lose any amperage through the second one? I did not. And through the third one, I did. So, and then I still have 1.7 amps going through the bottom. So once again, this is tricky. I have 4.4 amps coming down. I lost some of my amperage here, so I had volts and amps here. What does that mean? That's good. Now, load number 2, I have 3.15 amps possible here, and I still have 3.51 amps. So I'm going to check my voltage on load 2. Okay, we should know the problem right there. Okay, let's put another bug in it. Turn it on. Check amps. I have no amps. So I have no amps coming to my loads. Let's see if I have any voltage at source. I do have volts here across my fuses. I keep the same voltage across my start winding. The same voltage. Come down across my switch. Does my switch work? My switch does work. Come over to 4. Should still have the same voltage I do. I'm going to check wire 1. I'm going to check wire 2. I'm going to check wire 3. Okay, so I have voltage here. I have no voltage here. And I have voltage across the wire. So I know the problem there. Okay, let's put in another bug. Okay, once again, I have no amps. No amps. Let's go to our source. I have no voltage at the bottom of the fuses. I have voltage at the top. So is fuse 2 good? Fuse 2 allows voltage to go through it. Let's check fuse 1. Okay, I lost voltage right there. Do I have voltage across the fuse? I have voltage across the fuse. Okay, so that gives you an idea there about job number 18, using volts and amps to be able to detect a problem. The crucial part, most important part of understanding job 18 is seeing how that any one of these loads shorting will shunt the other loads. So I would have amperage here, here, and not here. That would mean that if I had the same amperage here, here, and here, and nothing here, that all of that amperage went through 3. So if I measured voltage here and had no volts and amps, then I would see a shunt of load 4, 2, and 1. Load 3 would be shunting those others, bypassing the electricity. All right, thanks a lot.